All right, so here we go with this review sheet. So remember, you have to show your work here. All right, so let's see. All right, so here's our exponent rules. So remember, exponent rules require us to multiply, add, or subtract exponents. So to simplify this, when I multiply, I am adding my exponents. So the numerator would become 8. And then I'd have x squared times x1, so it'd be x to the third. 2 plus 1 is 3. Then y and y to the fifth. I would get y to the sixth. Okay, so I'm not sure why this computer is lagging a little bit. Let me go and close some other stuff here. Maybe it'll speed it up a little bit. Okay, all right. It's still a little bit weird, but whatever. All right, so 2 to the third down here is 8. 2 times 3, because when you have a power and a power, you multiply. So that would be x to the sixth. And then this is a 1, so 1 times 3 is 3. All right, so now I divide, so I am subtracting my exponents. These two things cancel. 8 divided by 8 is 1. 3 minus 6 is negative 3, so that tells me I have x to the third in my denominator. 6 minus 3 is positive 3, so it tells me I have y to the third in my numerator. There's my answer. All right, number 2 says rewrite each radical expression as an exponential expression using rational or fraction exponents if you need to. All right, so the cube root of 125, 5 times 5 times 5 is 125, so that popped out. Remember that then I have my power over my root. So my power is 6, my root is 3. So my exponent over my index. And then I have 2 over 3. Well, 6 over 3 is 2, so that leads me to my answer there. All right, here, square root of 49 is easy peasy, 7. But then I have my 5. Remember, this is a square root, so I have 5 over 2. And y, this is a 1, so 1 over 2. And so just writing them in a different form. Okay, all right. So down here, this is from the answer sheet, and I pretty much already did them by actually putting the answers here. These are perfect squares, and when you have a subtraction with perfect squares, you may just split them up. You know, m squared splits them to mm, 7 and 7, and 1 plus and 1 minus, because what happens there is when you're multiplying, m times m is m squared, m times negative 7m is negative 7m, the inside is positive 7m, and the last part is negative 49. So these cancel, and you get what you started with. So again, these just take looking at to kind of split them apart. In a way, you're also doing like the square root of this to put here. And you're doing the square root of 64 to put here, and plus and minus. The only one that takes a little bit extra work is letter E. You have to take a 2 out first, and then that leaves you x squared minus 9, which then splits up into x plus 3 and x minus 3. All right. Over here, write this as a radical, so 1/2, remember, means square root. Let's put 25x squared in there. So square root of 25 is 5, and 2 goes into 2 one time, so everything comes out. 1/3 cube root, so we got 64, x6, y2. Cube root of 64 is 4, because 4 times 4 times 4 is 64. Or you can break it down and bring out 2 2's, which is 4. 3 goes into 6 twice, so x2 comes out. 3 does not go into y2 at all, so that just stays in there. This guy, so you can view this in 2 ways, 125 squared and then cube root. Well, that's a little bit difficult because 125 squared means I have to do 125 times 125. Well, I'd rather do 125 cube root, and so that's the bottom first, and then I can square that because I know the cube root of 125 is 5. So this is just 5 squared, which is 25, a little faster. All right, and, or, you know, you can put that in your calculator as well. All right, this is already written, so I'll just kind of explain these answers here. So, let's see. I have a square root function. It starts here and then continues on up. It is increasing the whole time. All right, so from 1 on, It's increasing. Remember, you never use brackets, always parentheses. It doesn't decrease at all, so there's no decreasing area. My domain is from 1 over, so 1 to infinity. It starts at 1, it touches 1, so bracket. My range is here. It is from 2 up, so same thing. So this graph, this radical function, the square root function, has been moved to the right 1 and up 2, so x minus 1 plus 2. You could also graph this on Desmos to check it out. All right, and for this bottom part. So if I'm going to be working this out, I got to break down 108. 108, I'll just do 54 times 2. 54 is 9 times 6, 3, 3, and 3, 2. So I'm looking for triples. I got triple 3 right there, so I'm bringing a 3 out. There's already a negative 3 waiting. So 3 times negative 3 is negative 9. Then I have a 2 times 2 left inside, so that's where I'm getting that 4 right there. All right, 3 goes into 7 twice, so x2 is out, but there's 1 left. 3 goes into 3 one time. And don't forget to write the cube root. Right, down here, 32. 8 times 4, 4 times 2, and 2 times 2. This is another 2 times 2. So I'm looking for groups of 4. So 1, 2, 3, 4. So 2 comes out, 2 stays in, this guy right here. 4 goes into 4 one time. 4 goes into 6 once, but there's 2 left. There we go. All right, for letter A over here. So remember, with adding and subtracting, it's very strict. You have to look exactly the same to add and subtract. Okay, so this one's finished. 18 is 9 times 2, and 9 is 3s. So I got 2 3s. So I'm bringing out a 3. There's already a 4 waiting. So negative 3 radical 2 will not change. This is 3 times 4, so it's 12 radical 2. 50 is 25 and 2. So 5 and 5, so 5's coming out. 5 times 4 is 20. So these all turned into radical 2's. So I just combine like terms. Negative 3 radical 2 plus 12 radical 2 is 9 radical 2. So 9 radical 2's minus 20 radical 2's is negative 11 radical 2's. Down here, 12 is 4 times 3, and this is 2 and 2, so I'm bringing out a 2. 2 times negative 5 is negative 10. Leave a 3 inside. Square 16, I don't need to break down, that's just a 4. 27 is 9 times 3, and then 3 and 3. So I'm looking for a square root, so a 3 comes out. 3 times 5 is 15, leaves a 3 inside. So this negative 4 is going to stay, and I can put these two things together. So negative 10 plus 15 is 5 radical 3. Okay, on the back side. So on the back side, when I am solving this, I need to get rid of this multiplication by 2, so I divide. So I have the cube root of 2x minus 6 equals 4. To get rid of the cube root, I will cube power. So this cancels out, because remember, a cube root is a 1/3 power, and I'm multiplying that by a 1/3 power, so those cancel. All right, so 2x minus 6 pops out. I got 64. So now I just have to solve this Algebra 1 problem. Add 6 to both sides, get 70, and divide by 2, I get 35. All right, remember another way to write this would be a square root. So if you really want to, you could write the square root of x minus 7 equals 10. So you could write it like that if you really want to. But I got to get rid of the 5 no matter what. So x minus 7 to the 1/2 equals 5. To get rid of a 1/2 power, which is a square root, I will square both sides. So this knocks each other out. X minus 7 equals 25. Add 7 to both sides. There's my answer. Okay, for number 10. Number 10, it tells you that x minus 3 is a factor of this. So I'm going to start with my synthetic division and put a 3 in the box. So I put 2, 3, negative 32, and 15 across here. So I bring my 2 down. 2 times 3 is 6. That adds up to 9. 9 times 3 is 27. That adds up to negative 5, which gives me negative 15 and a 0. So I had x to the 3rd. That means this is x squared, and x So I'm trying to solve this equation now. 2x squared plus 9x minus 5 equals 0. So when I do that, I'm going to try to factor it. So 2 times negative 5 is negative 10. Put a 9 down here. So I think I'll be using 10 minus 1 to make 9 and also negative 10. So that puts me to having x plus 10 and x minus 1. I'm not putting it here because it's not my answer. I had to divide both of these by 2. I multiplied by 2 to get the 10. All right, so this becomes x plus 5 and 2x minus 1. So my factor here and these next two factors I found, there they are. So those are my factors. Here are my solutions. Remember the opposite. 2x minus 1, if I set 2x minus 1 equal to 0, I add 1, divide by 2. There we go. Opposite. Okay. Same thing goes on number 11, except you're just given the information a little bit of a different way. You're saying that negative 2 is a root. So I don't change the sign, I literally put negative 2. It's one of the roots, one of the x-intercepts. And then I take the numbers. 3, 5, negative 4, negative 4. Bring down my 3. 3 times negative 2 is negative 6. Add them up. Multiply to a 2. Add them up. Multiply. And I got 0. Okay. All right, so I got x squared again and x because this was x to the third and I took 1 out, so I have x squared. So again, I'm trying to solve this. So I think we'll try to factor again. If not, you could always use a quadratic formula. You cannot solve by square roots because it has that x term in the middle. All right, so let's check it out. 3 times negative 2 is negative 6, and we got a negative 1. So we'll have to use negative 3 and 2, because those add up to negative 1, they multiply to negative 6. So that's x minus 3, x plus 2, but I have to divide by 3. So the factors are, let's see, x minus 1 and 3x plus 2. Okay, so there's my two factors, and if I turn this into a factor, it's x plus 2. So you got those, and then you got your solutions. So you just, you know one of them is negative 2, and then if you set this equal to 0, the answer is 1. If you set this equal to 0, take away 2, divide by 3, there's your other answer. Okay, last two. So for number 13, it's basically the same, and we'll do 12 in a second, but 13 is basically the same as the other ones. It's just give you a picture. So my factors and my roots, here's my roots. My roots are my x-intercepts, are negative 3, 1, and 2. And turn those into factors, the opposites. Right. Over here, 27, so g of 4. So when you do g of 4, that means that you replace 4 for x. So it's 5 times 4 plus 7, and then you work it out. Oops, I didn't need this parentheses here. So it's 20 plus 7, 27. This right here are composition of functions. So that means f is the boss. I'm taking this expression, 2x minus 3, and in place of x, I am placing g of x in there. So I'm putting, instead of putting a number in there, I'm putting a whole expression. I'm putting 5x plus 7. So you work it out. You get 10x plus 14 minus 3. And so this turns into 11, so there's my answer. All right, and then this guy, g of f of x. So that just means that g is the boss. So I write this down. 5 something plus 7, because that x gets replaced with f of x. F of x is 2x minus 3. Work it out. 10x minus 15 plus 7. So these two go together, so I get 10x minus 8. All right, that is it. See you in class.